Here is the question. I will describe the question like the main part of the question is like 20-meter depth of the well. So this is the well which is 20-meter and the diameter is 2 meter. So diameter is 2 meter and depth or height is 20 meter. A pump installed. So this is the pump which is installed to empty the well. So the main task of this pump is to empty the whole well. After pumping out half of the water, so this half portion is empty. It means that total is 20 meter. It means this half portion, so this is 10 meter, right? So this is 10 meter. So this half portion empty, and in that time the pump breaks down or the pump is not workable. Another pump installed here, let's say another pump installed here, and the power of the pump is same as the very first one, and the very first one power is given is 5 horsepower. Somewhere here is missing, so let's say 5 horsepower for the first, and the second one also given in the question, so this is also 5 horsepower. First question: calculate the amount of work done by the first pump. So the equation for work done, W equals to mg, and as the very first pump empty half of the water, so in that case the effective height will be h prime is equals to 20 plus pardon, this will be not 20, so the effective height h equals to, so it will be 10, and here is 0 over 2, so it will be 5 meter. So for first pump work done is W1, let's say, and this is h prime. So let's plug in the value mg h prime. By the way, we haven't got the m as well, so we have to find out the value of m as well. Indeed, the whole height of the well is obviously 20 meter. Now what we have to do, we have to calculate the volume of the well. So volume is equals to pi r square h prime, actually not h prime, it will be pi r square h, because whole water within the well is h height. So what we have got, we have got r, so r is equals to d over 2. So here will be d square by 4 and h. Let's plug in all the value. So after plugged all the value, we have got the volume of the well will be 62.832 meter cube. So this is the volume of the whole water of the well. Indeed, what we have to calculate the mass of the water within the well. So m is equals to rho times the volume, right? So rho of the water is 1000 kg per meter cube, and this is 62.832. So the mass of the water, we have 62 832 kgs. This is actually the total water of the well. But what we have done the half of the water pumped out. So for the very first pump, the M1 will be M over 2. It means we have got 31,416 kgs. Now this value need to be plugged here, right? So this is 31,416 9.8, and the value of H is 5. So altogether, the work done for the very first pump is 1.54 times 10 to the power 6 joule, or we could write down 1.54 megajoule. So this is the answer for the very first part of the question. Now the second part, analyze whether it will take the same amount of time for first and the second pump. So what we have to calculate, let's read one more time for the second part of the question, that analyze the same amount of time for first and second pump, their respective portion of the water. So the very first pump pumped the half of the water of the well, and second portion of the water of the well pumped by the second pump, and the power of the second pump same as the first one, which is 5 horsepower, right? So for case 1, let's say case 1, the pump 1, right? So pump 1, the power P in actually, which is 5 horsepower, which is actually 5730 watt, as well as the power of the second pump. So P in for first pump and the P in for second pump same, which is 5 horsepower or 5730 watt. And the work done for very first pump W1, which is 1.54 into 10 to the power 6 joule. And let's consider the time taken by the first pump, that is T1, and for second pump, that is T2, right? So for first pump, P1 is equals to W1 by T. So what we have to calculate, T1 and T2, and we have to analyze that T1 and T2 is equal or not. That we have to calculate, right? So the value of W1 we have got, P1 as well we have got. So T1 is equals to P1 is equals to 1.54 times 10 to the power 6, and P is 57, pardon, this will be 37, I beg your pardon, I made, so this will be actually 3730, actually 5 horsepower means 5 times 746, so it will be 3730. So T1 is equals to 412.87 second, right? Now for P2, P2 is equals to W2 and T2. So we have to calculate T2 is equals to W2 over P2, and P1 and P2 are equal, so it will be 3730 as well for P2. But what is W2? So W2, say now the second pump, let's change the color of the pen. Let's take the red one. So this half portion we have to pump by the second pump, right? Indeed, already we have got the depth here is 10 meter and here is 20 meter, right? So the effective height H2, let's say this is H2. So the effective height for the pump 2, H2 is equals to 20 plus 10 over 2. So it will be 15 meter. Now plug in the value here. So of course the value of W2 is mgh2 over P2. So what is the value of M? This will be actually M2. So the mass of the whole well is 62382 kgs and half is 31416. So M2 will be half as well. So it will be 31416. This is 9.8 and height is 15. The effective height for pump 2 and the power same as 3732. So here the value will be 1238.61 second. So T1 is not equals to T2. So we have analyzed that T1 is not equals to T2, but T2 is greater than T1. So our analyzation have done. So T2 take more time compared to the very first pump, more than like 3 times actually taken. Why? Because the bottom part of the water of the well it have taken by the second pump need more power. It means that more time also required, right? Though the power is same of the pump, so indeed to make the work done, more time is required to pump out all the below water of the well. Indeed, 3 times more time taken to pump the water. Hope you understand. If there any a question, please make a comment on the comment section. I'll answer as soon as possible. The very first part, how much work done by the first pump. So here actually another pump need to be used here. Let's understand the question first. Water filled well depth is 10 meters. So the depth of the well is 10 meter. Diameter is 2 meter as given. A pump can empty the well in 20 minutes. So by using this pump, it requires 20 minutes to empty the pump. To reduce the time, one more pump, the capacity of another pump, which is this one. So the capacity of this pump is actually 1 horsepower. So first question, the work done for the very fast pump. Second question, based on the given information, how much time can be saved when we added this second pump? So the very first question, how much work done by the very first pump? So first pump work done W1 is equals to, very straightforward, mg h prime. Why h prime? Because the effective height, right? So h is 10 meter. So effective height h prime is equals to h plus 0 divided by 2. 0 means this height, and here is 10. So 10 plus 0 over 2 is 5 meter. And the value of m also not given straight from the question. So we have to determine the value of m. But the height is 10, diameter is 2. Indeed, we could calculate the volume, right? So volume is pi d square, means d square over 4, and the height, right? So if we plug in all the value, so what we have got, the volume 31.416, 31.416 meter cube. So this is the volume of the water of the well. Now what we have to calculate, the mass of the well, I mean mass of the water within the well. So that is rho and the v. So rho is 10 to the power 3 and v is 31.416. So the value of m is 31416 kgs. This will be 6. And how much, so how much will be the work done by the very first pump? So plug in the value of water, that is 31416 times 9.8 times the height 5, right? So the total value of the work done by the very first pump, let's write down here, that is 15.394 times 10 to the power 5 joule. So this is the very first answer of the question. Now the second one, how much time can be saved? So the very first one, the pump work done is this much. Now we can calculate the power of the first pump, that is W1 over T. So the time taken empty the well, that is actually 20 minutes. So 20 times 60, and W1 is equals to 15.394 times 10 to the power 5 joule. So what we have, the P1 is 1.72 horsepower. We actually written directly in horsepower because the second pump also in horsepower. That's why here we have written the horsepower. So the total power, to reduce the time, in the total power P1 plus P2, that is actually 2.72, because P2 is 1 horsepower, so 2.72 horsepower, or we could write down the value of as the amount of water is constant. Indeed, we could write down actually P is proportional to 1 over the time. So indeed, we could write down P1 over P is equals to, so this is the T2 time, which is actually the T2 represents the new time when we added the second pump. Indeed, this is T2, and the first T1, which is actually this one for the very first pump, worked and taken actually 20 minutes to empty the well. Anyways, now what we have to calculate? We have to calculate the value of T2 actually. So T2 is equals to P1 over P and the time T. So the value of P1 is nothing but 1.72 and P is 2.72 times 20 into 60. If we would like to convert the value in second, let's get this value in minute actually. So indeed, put here 20 minutes. So what we have got, the value is 12.65 minutes. So before it was taken 20 minutes. Now after added this second machine, it means the total power enhances or increased to 2.72. In that time we have got 12.65 minute. So how much time we can save? 7.35 minute, or in the other hand we could write down 7 minute and 21 second. If you have any question to convert from 3.75 minute to 7 minute and 21 seconds, I will answer if you ask me. The question is, from a certain place shown in an image, an engine can lift a body of mass 100 kg to a height of 20 meter in 1 minute. It given that 30% of engine power is lost. What we have to determine? Determine the amount of work done by the engine. That is our very first question, and analyze mathematically whether it is possible to determine the total power of the engine given the logical justification through the calculation. So the very first one, what we have to do, we have to calculate the amount of work done by the engine. So the engine has shown here, and the capacity of the engine is not given, but the lost power is given. So if the lost power is 30%, so efficiency will be 100 minus 30%. So the efficiency is 60%, right? And the mass of this object is 100 kilo, and the height from the ground to 20 meter also given, and the time taken lifting from ground to 20 meter, that is 1 minute, which is 60 seconds. So the very first question, what we have to calculate, we have to calculate the work done. W is equals to mgh. Let's plug in all the given value. So this is 100 kilo of the object, and g is 9.8, and h is 20. So altogether we have got the total work done have done by the engine, that is 19,600 joule, or this can be written as 19.6 into 10 to the power 3 joule. So this is the answer for the very first part, the total work done have done by the engine. Now what we have to do, analyze mathematically whether it is possible to determine the total power of the engine. So here actually I have done a big mistake, that is it should be 70%, beg your pardon, it would be 70%. So be careful when you write down something during the revision or review, you have to check whether your answer is correct. Whatever you have written down on your script, that has to be checked and checked, right? Anyways, so the efficiency is 70%. What we have to do, is it possible to calculate the total power of the engine? So let's try. So here is the engine as we have seen here. So this is the input power, P in, and this is the P out power. So here is the loss. So 30% is loss. So efficiency is equals to P out over P in into 100%. So efficiency is how much? 70%. And here P out means the total work done, that is W, over T means the power, the output power will be the total work done by the engine, and the time taken by the engine, that is of course 60 seconds, and P in. So what we have to do, we have to calculate the input power of the machine. It means that the question was, is it possible to calculate the power of the engine? That is actually P in. So P in is equals to, so output power is 19.6 into 10 to the power 3 over 60, and efficiency is 70%. So it will be 7. So the final answer will be 466.67 watt. So this is the power of the engine. So this amount of power applied to work done for this amount, right? So two answers have done. To solve this problem, we have to understand the question. So here is the water filled well. Diameter is 4 meter and the height is 10 meter. A pump power of 6.87. So this is the pump, and the power, let's say this is P1, 6.87 horsepower, is used to empty the well in 20 minutes. However, after pumping out half of the water, the pump breaks. So half of the water pumped by the very fast pump, and afterward this is not workable. So if it is zero height and up to this one is half of the total height, so it means this is 5 meter, right? And after then this is not workable, and then another pump need to be used to empty the remain water within the remain time. How long the very first pump work? So indeed the very first pump worked for, let's say, t1 time that we have to calculate, and P1 is equals to nothing but, in horsepower convert to watt, is 5125.02 watt. And here the effective height H is equals to how much? So here H means, so half of the well empty, so half means 5, so the effective height will be up to this much, right? Up to this much means effective height, let's say H, this is actually effective height for very fast pump, so 5 plus 0 over 2, so the effective height will be 2.5 meter. So calculate the time, we have to calculate the work done by the very first pump. Indeed, we have to calculate the mass of the half of this well water. Indeed, we have to calculate the volume of the well. So pi r square h. And here are also given, which is diameter is 4, so r is 2, so pi 2 whole square, and h is 10, right? So the volume is 125.664 meter cube. So m is equals to rho v, so it will be multiplied with 10,000, so 125.664 times 1000, so very straightforward, 125.664 kg. This is the total water within the well, so half water have taken out, so m1 is equals to half of this amount, so it will be 62832 kgs of water, half of the well. So P1 is equals to W1 over T1. So what we have to calculate? We have to calculate the time period taken by the very first pump to empty the half of the well. So T1 is equals to W1 over P1. So here M is 62832 9.8, and the effective height is 2.5, and P1 is 5125.02. Let's calculate. So the time is, of course, in second, so this is 300.366 second, or in minute is 5.00. minutes. So the very fast pump need to work within 20 minutes, but it actually worked for 5.006 minutes, and afterward it broken, right? And then second pump need to be introduced, and now it's time to calculate the power of the second pump, and let's compare with the very fast pump. So as I said, the total time need to empty the whole well is 20 minutes. How much time it worked, that is 5.06. So this one minus 5.006 minute, so 14.994 minute remains, right? So remain water, let's say M2. So half water of the well is 62832 kgs. So remain half water also this amount of kgs, right? So M2 also 62832 kgs. So it will be 62, how much? 62832 kgs. So for second pump, this one, so here is 5 meter, right? So 2, and this much is 10. So effective height for second pump need to be somewhere here, right? So indeed, what you have to calculate, the effective height H2 is equals to 5 plus 10 over 2, and that is actually 7.5 meter. So all the data we have got right now to calculate. Okay. So P2, the second pump, W2 is equals to T2. So this is the value for actually T2. So W2 is nothing but M2, G is same for every case, and this is actually H2 and over T2. Now plug in all the value we have got. So this is how much? Let's copy the value 623. So this is 62832 kgs, and this is 9.8, and height is 7.5, the effective height, and T2 is how much? 14.994. So it will be 14.994. Let's convert into seconds. So 60 need to be multiplied with the 14.994 minutes. So what we have got, the value that is actually 5133.32 watt. The very first pump, which actually worked for 5 minutes, more than 5 minutes actually, that was 5125 watt, and in horsepower it was 6.87 horsepower, and this is the second pump, that is actually 5133.32 watt. So it was 5133 25 point actually 02. So the second one a slightly bigger actually in power, almost similar, right?